So far we've been solving systems of equations by graphing. We take our two equations, graph the lines on the graph, see where they cross, and that's our solution. Sometimes we had to convert them to slope-intercept form first, but it's been basically the same every time. Today we're going to do a new method called the substitution method. The way that this works is we're going to solve one equation to find out what one of the variables equals, and then plug it back into the other equation to solve the entire thing. That might sound confusing, but here's how it works. This one equation I have says x equals y plus 7. So that means that wherever I see x in this other equation, I can instead put y plus 7. So I'm going to substitute y plus 7 in place of this x. So I have 2 times x, which I'm going to put an open parentheses here, plus 2y equals 34. Now, I know that x is equal to y plus 7, so in place of x, I'm going to put y plus 7. Now all we're going to have to do is simplify our equation and solve for y. So, right now I'm going to distribute this multiplication of the 2. So 2 times y is 2y. 2 times 7 is 14. Bring down my other 2y and my 34. I have some like terms here. 2y and 2y combine to make 4y. My 14 comes down, equals 34. I can solve this two-step equation by subtracting 14 from both sides, leaving me with 4y equals 20, and then divide both sides by 4, and I get y equals 5. So we're halfway there, but we still need to figure out what x equals. So what I'm going to do is I'm going to go back to my original equation over here, where it said x equals y plus 7. And now I can plug in this y value that we had in place of y. So I have x equals y plus 7, and now I know that y is 5. So 5 plus 7 gives me x equals 12. I can just quickly check this in my head to make sure that it makes sense. This says 12 equals 5 plus 7. That makes sense. In the other equation, I have 2 times 12 is 24, plus 2 times 5 is 10, and 24 plus 10 is 34. So this looks like a lot of writing, but it's just skills that you guys already know. Now it's time to try another one. Pause the video, try this one out on your own, and then check your work with mine in a minute. Alright, so I see that y equals x minus 5. So I'm going to substitute x minus 5 in place of y. So that's 4x plus 3y equals 27. And I know that y is equal to x minus 5. So I'm going to substitute x minus 5 in there. 3 times x is 3x. And 3 times negative 5 is negative 15. This is all equal to 27. I'm going to bring down my 4x. Now I can combine my like terms. See, 4x and 3x make 7x. Bring down my minus 15 equals 27. Going to add 15 to both sides. Which will give me 7x equals 42. Divide both sides by 7. And I get x equals 6. Now that I have my x my x value, I can take that and substitute it back into my original equation. Y equals x minus 5. And put that 6 right there. 6 minus 5 is 1. So my solution then is x equals 6, y equals 1. We can check it just to see if it makes sense. 6 minus 5 is 1. 4 times 6 is 24, plus 3 times 1 is 3. 24 plus 3 makes 27. I can just write my solution down here, just like we've been doing. 6, 1. That is the point on the line where these two intersect. And if you converted these both into slope-intercept form and graphed them, they would cross at this point. Alright, try this next one on your own. Pause the video, and then come back when you're done. Alright, so again I see that x is equal to 3y, so I can substitute this into the other equation. I have 4x minus 3y is equal to 36. Oh, I'm sorry. We're substituting this for x. So 4x minus 3y equals 36. I put 3y, substitute 3y in place of x. 4 times 3y is 12y. Bring down my minus 3y equals 36. I can combine my like terms. So I get 12 minus 3 is 9y equals 36. Divide both sides by 9. And I'm left with y equals 4. 36 divided by 9 is 4. By the way. Alright, now I can substitute this back into my original equation of x equals 3y. And in place of y, I'm going to put what I know y equals now, which is 4. So 3 times 4 is 12, so x equals 12. I can check my solution just to see if it makes sense. 4 times 12 is 48, minus 3 times 4, 3 times 4 is 12. 48 minus 12 is 36. So my solution then is 12, 4. Yay! Alright, now sometimes equations aren't already solved for one variable. As you can see here, I don't know what x or y is yet. But I can use my skills to get it by itself, just like we've been doing before. I see that y is alone here. It doesn't have a coefficient like x does, so I'm going to try and get it alone. I think that's going to be the easier way. So I'm going to subtract 4x from both sides of this equation. And that's going to leave me with y equals negative 4x plus 24. I don't know why my 4s are looking like 9s. Alright, so now that I know the value of y, I can take this, plug it back in place of y, just like we did before. So I have 2x minus 3y equals negative 2. And I know that y is equal to negative 4x plus 24. So negative 3 times negative 4x is positive 12x. Negative 3 times 24 is negative 72. Bring down my equals negative 2. Bring down my 2x. 2x and 12x makes 14x. Add 72 to both sides. X equals 70. and then divide both sides by 14. So we have x equals 70 divided by 14 is 5. So now I can plug this back into my other equation that I had here. I could plug it back into my original equation, but I think it's going to be simpler if I plug it into the one I already have solved for y. So I'm going to plug y equals negative 4 times x plus 24. Plug my x value in. And negative 4 times 5 is negative 20. And negative 20 plus 4, plus 24 is 4. So my solution then is 5, 4. I can check this with my other equations. 2 times 5 is 10, minus 3 times 4 is 12, 10 minus 12 is negative 2. 4 times 5 is 20, plus 4 is 24. Alright, try this next one on your own. Pause the video and come back when you're done. So you can pause the video again. Here's all my work. I didn't want to bore you talking through it all. So check it out. If you have a question, you can raise your hand and ask me in real life, because I'm also a real person. I'm not just in the computer. Alright, so this one is just the same. It's just going to take a little bit more work to get x or y by itself. You can do it with either one. So you can either get x by itself or get y by itself. It's completely up to you. But yeah, pause the video, try it out, and then check when you get back. Alright, so here's all my work for this one. As you can see, I chose to solve for y. You also could have subtracted 2y from both sides and divided by negative 2 to solve for x, and then plug x in over here, substitute x in over here. So you would have given you the exact same answer in the end. Our solution is 4, 8, and again, we could check it by plugging it back in, but I'm not going to do that right now. So, last problem. Psych, no, that was the last problem. Here's your classwork problems. You can do this on a separate piece of paper. I recommend pausing the video so that you can see the problems. If you have any questions, please, please, please ask real life Mr. U, who is in the room with you right now. He's a professional mathematician, and he's really smart because he's worked really hard at learning math. So, yeah. Also, you can go back and watch the video if you're confused about any of this.